All right, so this section is going to be all about solving radical equations. And those are exactly how they sound. It's just an equation that has a radical in it, whether it's a square root, a cube root, a fourth root, fifth root, doesn't matter. Okay. You have seen this before, correct? It doesn't mean you remember how to do it, but you have seen this before? A little bit. Today will be a little bit easier than tomorrow's lesson because it's going to be mostly review today. All right, let's do this. All right, number one, I'm going to start super simple. Say I had something like the square root of x is equal to 5. Okay. To solve this, you always have to do the inverse. If you remember before, we were subtracting things from both sides or multiplying something on both sides. You have to do the opposite in order to solve for x. Okay, so what is the opposite of square root? No one knows? Squared. Okay, so if you wanted, you can just do the square of both sides. Okay, so when you do that, the squared and square root cancel, and you're left with x is equal to 5 squared, which is 25, and that is the answer. Okay, I know this is like super basic, but we will get into more complicated ones as we go. Okay. The interesting thing about radical equations is that sometimes they don't work. I'm going to show you an example right here. Okay, so this is the exact same problem that we started with, only this time instead of x equals square root of x equals 5, it's equal to -5. So same rule applies. You're going to want to square both sides. Okay, cancel, cancel. You're going to have x is equal to -5 times -5, which is 25. But there's an issue with this. The original problem, if you look at just what was written in black here, what is the square root of 25? 5. What's written in black here, it says the square root of 25 is equal to -5. So that's a problem. And this might be a little bit new compared to what you learned in the past. This is not the answer, okay? That's called an extraneous solution. It's almost like an excluded value. No. Go in the hallway. Smart. Okay, long story short, this is an extraneous solution, and you would write for the answer no solution. Okay, you don't need to write extraneous solution unless it asks for that. But the answer for this one is no solution. Okay. Now, if you compare that to what we did in the original one, number 1, the square root of 25 is 5, so it does check out if you look at what's written in black. The moral of the story is when you solve radical equations, you have to check your work at the end. You have to check the answer. Okay? SAT will give you ones where they don't work. I will give you ones where they don't work. It'll be on the quizzes. It'll be on tests where there's going to be an extraneous solution. So you have to check your work. Okay? You have to plug your answer into the original and see if it actually works. If it doesn't work, then it's not counted. You cannot count it. Okay, are there any questions on that? The easiest way to do these, by the way, is if you ever get a problem where it says a square root of something is equal to a negative value, let's just say -9, it's impossible. You can't do the square root of a negative. You can't take the square root of something and it be negative. Unless you put a negative in front, this is possible. But if you divide both sides by -1, they're both positive now. Okay? But if you just have a regular one with just a negative, it's never going to work. That's why this one was so easy to make for me. I just knew it wasn't going to work if I made it negative. Okay, let's do another one. Now we're going to get a little bit, each successive problem we do is going to be a little bit more complicated than the one before it. Okay. So this one's the square root of x minus 7 is equal to 3. Okay. What is the first thing we should do? Add the 7. So we're going to add 7 to both sides, and you're going to have the square root of x is equal to 3 plus 7 is 10. Okay, now if you notice it's equal to a positive, so that means we're in the clear. We're good to go. But what do I do next here? Square both sides. What you do to one side, you equally have to do to the other. X is equal to 100. Okay, we have to check it, even though I said it was already going to work because of the negative. But the square root of 100 is 10. 10 minus 7 is 3. So it works. So because it works, that's the answer, and you're good to go. Sometimes what I do is I put a little check mark after I checked it. Just so like when I'm doing a test and say I didn't check my work on one of them, I'm like, oh, I didn't put a check mark on that one. I better go check it really quick. Good rule of thumb to follow for that one. All right, now I'm going to try to trick you here. See if it works. Number 4 is going to be the exact same problem. Only this time, instead of the square root, I'm doing the cube root. Ooh. What do I do now? Yes, what's the first step to solve it? Add 7 to both sides. So then you get the cube root of x is equal to 10. Okay, now what do I do? Do I square both sides again? You cube them, yes. Cube both sides. And when you do that, cancel, cancel. X is equal to 10 times 10 times 10 is 1,000. You can check it by plugging it into the original here. The cube root of 1,000 is 10. It's just working backwards here. 10 minus 7 is 3. It all checks out. All right. Questions so far? Too easy? Okay, number 5. Let's do the square root of x plus 7 is equal to 3. Okay, I want you to solve that out, and once you get the answer, just raise your hand, and then you can yell it out if you want to share it with the whole class. You already have the answer? Yeah. Go ahead. Okay, so we got no solution as a possible answer. Another no solution? Did anyone else get no solution? Okay. There actually is a solution to this. And the solution is that there is no solution. Okay, so check 7 from both sides. And you end up with a -4. If you want, right as soon as you see this, square root of a negative, just write no solution. But if you want to keep going for fun, which is not really fun, you can square both sides. Scott, I'm sure I'm going to trick you on the next one, so it's okay. X is equal to 16. Throw 16 in here. The square root of 16 is 4. 4 plus 7 is 11, not 3. So because of that, this is an extraneous solution. You cannot count it. So the answer is no solution. All right. Now, here we go with the tricking, possible tricking. You ready? This is going to be crazy. We're going to do x to the third root, cube root, plus 7 equals 3. Once you get the answer, if you want to just yell it out. Go. Negative 64. Did anyone else get that? You got that? Okay, that actually is not right. Just so you know. Sorry, it's incorrect. I still respect you as a person.
It is.
Just not as much. What? It is not right now.
You sure?
Yep.
But it's talking about the 4, and you actually get
Yeah, interesting. Okay.
it don't work. But the check's out. My God.
All right. Let's go over it then, Scott. So we have oh wait, maybe never mind. No, yeah, maybe you are right. I changed the problem from what it originally was, and I thought the answer would be the same. No, come on. All right. So yeah, I just embarrassed myself here. All right. Scott was right. Dang it. All right. Sorry, and other people were right too. I'm sorry about that. Okay. It's cool. It's humbling. We're gonna cube both sides here. Cancel, cancel. X is going to be equal to -4 times -4 times -4, which is -64. Throw it back in the original problem. You'll get -4 plus 7 is 3, so that does work out. I wanted the answer to be -8. I didn't want it to be some crazy number like this, but I didn't change the 7 and the 3 because I wanted to keep with the whole motif of 7 and 3 for all these. That's why. It's my fault.
Wrong.
Okay. All right. We're going up a step now. We're going to do 3x plus 5, the square root of this, minus 3 is equal to -2. Do not get tricked. Add the 3 to both sides. Moral of the story for this is always isolate the radical first. You have to have the radical by itself. That way when you square both sides, the radical goes away. So you need to get rid of the -3 so you can isolate the radical. So we're going to add 3 to both sides, and you're going to get 3x plus 5, the square root of that, is equal to 1. Okay. From here, now we can square it. If you square it right away, like let's just say you did this incorrectly, that's a nightmare, okay? Don't write this down because it's completely wrong. But if you actually did square this, it would look like this because you'd have to grid it out. Do not write this down because it's going to take me a year to do as it is. Okay, so this would be 3x plus 5. This is -3 times root 3x plus 5. This is -3 root 3x plus 5, and then 9. This makes the problem, I have to add all this up. This makes the problem way more complicated than if you just added the 3 to the other side and squared both sides. So again, the moral of the story is isolate the radical first. You have to do that. Isolate the radical. If you like writing down steps, then write that down as a step. Step 1, isolate the radical. So once you isolate the radical, now you can just square both sides. That gets rid of it. Now it's just 3x plus 5 is equal to 1. And that's for middle school solving this out. Subtract 5 from both sides, you get 3x is equal to -4. Divide both sides by 3, and you get -4/3. Okay. From here, you are going to want to check, does this actually work? So if you throw it back up here, you're going to get 4 plus 5, which is 9. Square root of 9 is 3. 3, wait, what happened? -4, that's embarrassing. -4, it's not 9, it's -4. Plus 5 is 1. Square root of 1 minus 3 is -2. Thanks, Scott. I caught it. It's not as embarrassing if I catch it before a kid does. Thanks for giving me a little buffer room there. All right, here we go. Let's do the third root of 6 minus x is equal to -3. Okay, once you get that answer, throw it in the chat, por favor. Because cubes and negatives are completely fine. Oh, I was supposed to say it. If you look at number, which one is it? Where is it? Oh, day. Oh, this one right here. Look at 5 and 6. For 5, it was no solution. For 6, it was -64. If it's odd, you don't need to worry about that kind of thing. So this is possible to do. And the answer wasn't no solution. Oh, you're thinking like a teacher. Scott won that race. Mm-hmm. All right, first thing we're going to do here, looks like 33 is the answer. We're going to cube both sides. Okay, then you're going to get 6 minus x here. -3 cubed is -27. Okay, I'm going to add x to this side, add 27 to the other side, and you get 33. Let's do -12 times the square root of x minus 6 is equal to 18. All right, try that one out. Then throw it in the chat. So one way you can do it, since it's a square root, you can divide both sides by 12, and you get the square root of x minus 6, and then you're going to get 18 over -12. I know that breaks down. So you can divide the top and the bottom by 6, so it's going to be 3 over 2, -3 over 2. You have the square root, and then it's a negative. You can't actually do that. And the reason why is because if you square both sides, this time you'd have to square all the sides. But when you square both sides, it automatically makes it positive, and it can't be positive because it's negative. Now, if it was like cubed or to the 5th power, it would keep it negative. So since it kept it negative, it didn't switch anything. But that gives you a false positive because of this. So if you did actually try to work this out, it's x minus 6 is equal to 9/4. You notice it's positive now because a negative times a negative is positive. You add 6 to both sides, and you would get 33 over 4. Because that's 24 plus 9 over 4. Oh, is it? Cool. I said cool. All right. So if you try to plug this back into the original, you'd get a negative because this is positive and this is negative right here. And you have a positive over here, so that is impossible. So because of that, it is no solution, which a lot of people put. I don't think so. There's a symbol for undefined. I think that's what you're thinking of. All right, number 10. All right, I'm going to give you, because I feel like we're about done today. Is that about right? I'm trying to read the room here. We're good? Okay, this will be the last one we do, and then I'll give you some bell ringer here. Let's do, or an exit ticket, I'm sorry. So this one's going to be x squared plus 8x equals 3, but it's the square root. This one mixes old stuff with new stuff, so it's kind of why I wanted to do it this way. Okay, first thing we're going to do is square both sides. Subtract 9 from both sides. So then you have a quadratic equation. You can use quadratic formula, or you can factor it. So this would factor to x minus 9, really x plus 9, and x minus 1 is equal to 0. X is equal to -9, x is equal to 1, but you have to test it by putting it back into the original equation here. Okay, so if you put -9 in here, you're going to get 81 minus 72, which is 9. The square root of 9 is 3. So that one checks out. Plug the 1 in there, you get 1 plus 8 is 9. Square root of 9 is 3. So both of those check out, and that is the answer. So very good.